When we talk about climate change, we often focus on carbon dioxide in the atmosphere. But have you ever wondered where carbon is actually stored on Earth? The atmosphere is only one part of the story. In fact, most carbon is stored elsewhere. Today, we'll explore the carbon pools on our planet, focusing on plants and soils, among others. Let's start with plants. Through photosynthesis, plants take carbon dioxide from the atmosphere and convert it into sugars. These sugars become leaves, stems, and roots. Did you know that about 50% of a tree's dry biomass is carbon? That means half of the solid material of a tree, excluding water, is made of carbon atoms. The other half includes elements like oxygen, hydrogen, nitrogen, calcium, potassium, and iron. Forests, therefore, act as major carbon reservoirs. As trees grow, they store carbon in their wood for decades or even centuries. This process removes carbon dioxide from the atmosphere and temporarily locks it into biomass. But plants are only one part of the picture. Did you know that soils store 2.5 times the amount of vegetation? Soil carbon is mainly stored as soil organic matter, often abbreviated as SOM. Soil organic matter consists of dead and decaying plant material, soil organisms, decomposed residues, and root secretions. And around 57% of soil organic matter is carbon. When plants shed leaves, roots die, or organisms decompose, carbon enters the soil. Some of it is released back into the atmosphere through respiration. But some carbon becomes stabilized and can remain in the soil for years, decades, centuries, or even millennia. Globally, soils represent one of the largest terrestrial carbon pools. This makes soil management extremely important in climate discussions. Carbon storage is not evenly distributed across the planet. Tropical regions store large amounts in vegetation. Temperate regions store carbon in both forests and soils. Boreal and colder regions store enormous amounts in soils, especially in peatlands and permafrost, where decomposition is slower. Carbon constantly moves between the atmosphere, plants, and soils. If more carbon is stored than released, we slow climate change. If more carbon is released than stored, atmospheric carbon dioxide rises. Deforestation, forest fires, and soil degradation can release large amounts of stored carbon. So in conclusion, understanding where carbon is stored is the first step toward managing it wisely and protecting our climate for the future.